Okay, so here we have a old Edexcel FP2 problem. It's from 2008. It was on FP3 in those days. I've chosen this one because we haven't seen for a while something that actually uses argument properties on past paper questions to actually work out the loci and the transformed loci. Okay, so let's just go through the earlier parts. Part A is fairly routine, loci problem. So I want to get that done quite quickly just for completeness sake more than anything. So let's go back to blue. Right, okay, so it's a loci problem. It's going to go anti-clockwise from top to bottom. It's a part circle. I don't want to go into any diagram at this stage, showing the angles, because I'm kind of keen to get onto the meaty part of part C. So it's a worthwhile knowing this. It goes anti-clockwise from the top to bottom. From top to bottom. Let's write that down. Don't really know what I'm writing there. Top to bottom. Okay. So let's just do it. Okay. I don't need to do that. It's okay. Right. So it's Z minus Z1 over Z minus Z2. As I say, argument. It's of this type equals alpha, which will be a part circle going from top to bottom. So Z1 is equal to 2i, so that's up there. Call it 2i, so that's 2i there. And Z2 is minus 2. Okay, so that's there. And it's a part circle. So it's going to do something like this. Excuse my dreadful drawing. Anyway, that's it. And we know the reason I knew it was going that way, I drew it clockwise, because it's anti-clockwise from the top to the bottom. So the top one was 2i. You can see there the arrow that I'm going around is anti-clockwise. So that means it's that's the given loci. So that's it. Nice easy 4 marks for the first part. Right, now for the second part, we can, it seems a bit unusual, but it's not. It's really a straightforward geometry problem, really, because you'll notice the center of this circle is represented by the complex number 1 plus I is the center of the circle, and Z1 is some point on this, or Z, not Z1. Z refers to a general point on that loci. So we can see that really all we're being asked for is the radius of the circle here, because Z minus 1 plus I is going to be equal to the radius of the circle. So that is then going to make it pretty straightforward, because we just need to find some way of finding a radius. Well, probably the easiest thing to do is to find this length here, and that's 1 across and 1 up. So that makes it square root of 2. Okay, bang, done. Okay, 2 marks. Actually quite a little bit of geometric interpretation. Notice really not, I mean, we're just using geometry there. We're, don't worry about the eyes or anything really. It's just a circle in a Cartesian plane. I mean, our Zan diagram, and we're using complex numbers here, but essentially we're just using Pythagoras. Square root of 1, 1 squared plus 1 squared is equal to 2, and square root in that. Okay, now for the part I really wanted to get onto. We're going to be using this argument properties here, and arguments actually behave a little bit like logarithms. And the reason we're using arguments problems is because our original, let's rub this out now, our original loci is expressed in argument form. It's a part circle. So we're going to use those properties, we're going to use that loci formula and transform it to get another loci formula using this rule here. and we're going to have to play around with it using these properties. And it's not for the faint-hearted, this, I can tell you, and we need to be careful with our algebra. Having looked at a few students' work, it can be pretty hairy. So we need to really be quite careful. Okay, let's just do it. Argument of z minus 2i over z plus 2. Right, that's our local, but we need to do our rearrangement first. I don't know what I'm doing sometimes. This is the thing we need to look at. We need to rearrange this to get z the subject of the formula. Come on, wake up. Right, z plus 2. Okay, never mind. Right, so I'm going to do it this way. W is equal to 2, 1 plus I. Just kind of cross multiply them. Z plus 2 even. Just writing the same thing again there. Well done, John. You're doing really well. Okay, so cross multiply them. And now bring those over. Okay, so there we go. We've got our z for 2 bracket 1 plus I, w minus 2. We've got rearranged. I'm going to leave it like this. We could put it over common denominator w, but actually I'm looking at our loci I've got here, and I've written here again. It's going to be quite useful having that, because the 2 is going to cancel. So I'm going to leave it like that for now and see what happens. So we've got argument of z minus 2i over z plus 2 equals to pi by 2. This means that, let's sub it in then, argument of z, which is this, 2 bracket 1 plus I over w minus 2 minus 2i all over 2 over 1 plus I over w minus 2 plus 2. As I said, I kind of noticed that that's going to cancel there. So that's going to, it's not particularly pretty, but let's try and tidy it up as much as we can now. We know that's equal to pi by 2, but let's bear that one in mind for the moment. So that gives us argument of 2 bracket 1 plus I over w. The thing I'm actually seeing here also is a common factor almost of 1 plus I. So we've got minus 2 bracket 1 plus I here. Just going to factorize it like that. And then on the bottom, I've got 2 bracket 1 plus I over w. Okay, let's put it over common denominator now and factorize a bit. So that gives us argument, the w will cancel if I do this now, 2 1 plus I over w minus 2 w 1 plus I over 2 1 plus I over w. Okay, I didn't really want to write that stacked fraction there, but some people might have asked me how I got rid of the w. So I'm going to get rid of that w on the bottom now. So sometimes I end up writing things I wouldn't actually write myself. So I probably would have gone straight to this to avoid the stack fraction. Now I'm liking this now because we've got a 1 plus I cancelling. Ka-ching. Isn't that good, eh? Seeing these things, doing a bit of tidying up and algebra. Well done for those students who've actually done this right. Some people's work are considerably longer than this, but you got there in the end, which is all very good. So that's 2 minus 2w over 2. Right, okay, so how's this all going to work? Let's factorize that. So that's going to be argument of 1 minus w. So let's go back to the original thing. It's still not done yet, still a bit of work to do, and that wasn't, I told you this wasn't for the faint-hearted. Argument of 1 minus w is equal to pi by 2. Now, we haven't got into our standard loci thing at the moment. What I might be tempted to do, go back to these loci, go back to this here. Right? If I times this by minus 1, or just call this argument of minus 1 times w minus 1 equals pi by 2, I can now separate it out. Argument of minus 1 plus argument of w minus 1 equals pi by 2. Now argument of minus 1 that's just there, isn't it? That's equal to pi. So we can say pi plus argument of w minus 1 equals pi by 2. So that's argument of w minus 1 equals minus pi by 2. So nearly there. It does want a diagram for this. This is one of the standard ones that we should know. It's a part line starting at 1 and going with argument pi by 2 with angle minus pi by 2. So here we go. Starting at minus 1, there is our loci. Part line starting at minus 1 and angle here, obviously minus pi by 2. Okay, haven't seen one like that for a while. You never know. It's the kind of thing that the powers that be at Edexcel would be perfectly within their rights to ask if they chose to do so. Okay, hope you enjoyed it. Bye.